So if you're ready, let's go.
Cool, I'm ready.
Okay, and we are live. Hello, Simon, and welcome to today's speaking session. This is the afternoon speaking session. We'll first have Simon from The Graph, who's here with me in the call right now. He will be giving a brief presentation and answering any questions you might have. And then right afterwards, we'll have LayerZero, who will be joining us for a fireside chat. That will take around 35 to 45 minutes. So welcome everyone, and hello Simon. Please get started with a quick introduction about yourself, about the graph, maybe how you got started with the graph and crypto in general as well.
Yeah, sure. Happy to. Hi, everybody. Thanks for having me. My name is Simon or Simon. Like people ask me, like, what's the real pronunciation? And my mom calls me Simon because I'm from Switzerland. Born and raised in Zurich. I'm doing like developer relations at Node, working on the Graph protocol. Yeah, my way into crypto, into Web3 was I did a lot of full stack stuff. Worked for clients, had my own startup, but then in 2017, when the ICO hype was going on in Zug, which is like nearby to Zurich in the so-called Crypto Valley, I was also was interested to do something else and looking for a new job, and then I found a company, but it was back in the days called Melonport. They are now the Enzyme protocol. So they did asset management on chain. I didn't have like that much of a background in asset management, but like it was very nice for me to jump into this. I was heading the front end team, so I built the whole stuff. Was looking into how to extract data from the blockchain, how can we display it, and yeah, that kind of stuff. Then I realized like it's a very hard problem. We will dive into this later on. To actually get the data from the blockchain, although it's there, it's not there very well structured. But we wanted to display it, and so I learned about the graph at some point. And then fast forward, at some point I decided to join that team and bring that graph thing forward.
Nice, awesome. Thanks for the intro. So feel free to just take it away.
Okay. So how do we do that? I can just share my screen. Isn't there a way to share into, oh. Okay, it seems like I need to quickly close the window and come back. Is that okay?
Yeah, for sure, for sure.
Sorry about that. I am back.
Hello, welcome back.
Sorry for the new error, but like I usually use Zoom.
I see.
I would say I just share my whole window. Okay. Can you see my screen? But do you also see that overlay here or not?
We don't. The entire overlay isn't visible, so it's just your screen.
Okay, nice. So you see just the presentation.
Yep.
Perfect. Then let's dive into it.
All right, let's go.
Okay. So hi, my name is Simon. As I just mentioned, I manage developer relations for Node, and we're working on the Graph protocol. We'll dive into this. Node is one of the core development companies working on the Graph. There are others like Streaming Fast, Semiotic, Messari, GraphOps. But yeah, Node is the original team, and is having the developer relations team there. And today in this talk, we look a little bit into the idea of how we can use Web2 data or supercharge Web2 data with Web3 technologies. Or like in a way more technical explanation, it's like new use cases, derived from transforming subgraphs into read-oriented rollups. That sounds a little bit crazy, but we'll go into it like step by step. I think in the end everything will be very clear. Otherwise, we can also have some questions. Yeah. All right. Then, yeah, Web 2 data. It depends if you would consider yourself already a Web3 developer or you're interested. But like the funny thing about the people like me that work in this thing called Web3 is that we think it's the next iteration of the web, so the next evolution. And we currently live in basically mostly in the Web2 world. And the next thing that we're currently building will be the Web3 world. But Web2 data is traditional data. That's or like not traditional, it's just the data that we actually used to. So one could be airplanes that have seats. So we go online to book airplane seats or our flights across the world, and all that happens on centralized servers. But that this idea, these seats and which planes go where, and do they have like any free seats, and what would be the price? That's something that I see is Web2 data. Or then the other image here is hotel rooms, also something that we could see as Web2 data. Is like there are hotels across the world. They have names. They have like rooms. They have empty rooms and occupied rooms and prices and fluctuating price and so on. So that could be another data set that might be interesting to bring into Web3. Then even more interesting idea, actually, I think is the one that I tried with Mid Journey here about weather data. So we could think about um, a lot of weather stations, independent weather stations that are out there that we could maybe tap into and get that data somehow into Web3. And lastly, like a very traditional thing is a server data, which means like response times to web service, or if several web services are talking to each other, it's like how quick was that response time, or like analytics about like how do people open websites, something like that. So this is what I think is roughly Web2 data. So basically data that we currently as developers in a day-to-day job are working with. The characteristics of that data is compared to Web3 data, it's that usually it's in silos. So it's on a server. Usually there's access control to that server. And more often than not, the companies that own that data think that it's somehow their intellectual property or something to defend. They are like very reluctant of giving access to that data, which leads to duplication of data and so on and so forth. That is a whole problem space. So okay, so we see that data, the Web2 data, and then we think like, okay, so how can the graph help? So maybe we should just like jump quickly into what is the graph. So when you can think about the graph is like is this, so it is organizing blockchain data. So we have a lot of data on the blockchain. When we talk about blockchain data, it's Web3 data. What's the difference between Web2 data and Web3 data? Web3 data is usually accessible for everybody. Like everybody can just run a blockchain node and participate in the Ethereum blockchain, and it gets all the data. Everything that happens on Ethereum will be automatically mirrored to the blockchain node if you want to run one. And the graph brings, like there's a lot of data. It's hard to get access, and the graph orders that data, makes it easy to access. So this is somehow can be seen as like we have front ends on the top that are querying data, and then we have a subgraph, usually smart contracts that we want to interact with. They run on a blockchain, and the graph sits in between, like in between the front end and the contracts and the blockchain sits the graph, and that is an indexing and query layer that has all the data that's important for Web3 ready to be queried from front end or other data science applications. If we see a new class of data consumers coming up. So we can also talk about like it's the data layer of Web3. It's in the middle in a typical system architecture. Maybe at some point we would set up data layers, and for Web3, we can maybe think that the graph is that data layer. The graph is also a Web3 data, so it's decentralized. Again, like everybody can run an indexer. So currently there are 257 indexers, like independent indexers across the world participating in the graph network, indexing that data and making it available to be queried. Then this number actually surprised me almost a little bit by myself. It's like we have now over 100,000 delegators. Delegators are delegating to the indexers. It's a way to put the GRT to work. And with the switch to Arbitrum, it's so cheap to participate in the network, so that we have a lot of people that are doing this. So if you want, you can also do this. Then we have the curators, a little bit smaller number because it's a more complex thing to do. And then almost 2,000 subgraphs already deployed to the decentralized network. I mean, it's quite a lot. So it's something going on. It's happening. To date, we have 3.11 million GRTs processed in query fees. They flew into the network. So like when people query from the graph network, they also pay in GRTs. That these are making query fees. So that's kind of, that thing is running. So we have in the end, we end up with what we call the truly decentralized data. So we have data here in a decentralized network that is accessible. Okay, so we talked about Web2 data. We talked about the graph, and also maybe a little bit touched on Web3 data. But let's look into this idea of read-oriented rollups. So we can think of like that data in a subgraph flows like this. So we have first we have the blockchain on the left side. The blockchain is basically the source of data. That's the truth. And then the blockchain, like we know, it's like every time, it depends on the blockchain, there will be a new block created. The block contains new data. So we can also think about it's a data stream that streams from the blockchain to the mappings in subgraphs. That's how the subgraphs work. So subgraphs have a thing called mappings that take a blockchain stream in and process that stream, store it into a database. In fact, it's just like a Postgres database that runs on the graph nodes on the indexes. And these mappings can also read from the store. Currently, it's mostly written in assembly script, but we are also exploring the idea of using more of Rust, the new cool programming language. And then in the end, on the right side, a data consumer can just query data from that store, from the subgraph, right? And this is actually where I think the magic happens, because the mappings and assembly script and Rust, these are Turing complete programming languages. You probably know the Alan Turing and the Turing machine and Turing completeness. That means that if a programming language is Turing complete, basically we can do everything with it. And that's the same with subgraphs. So we can start to think about subgraphs as a thing that's not only just storing data, but also that helps processing data and also maybe even offloads data processing from the blockchain, from smart contracts into the subgraph. That's actually interesting. So that idea started it's almost 3 years ago, 2.5 years ago. I mean, it's probably not the first one, but that did it, but it was just funny. And they said hey, we can actually use the subgraphs, and then we inherit the security of smart contracts. And then with assembly script, we can maybe build a blockchain that's kind of triggered through the blockchain on top with subgraphs. A little bit weird idea, sounded a bit strange, but it's true. It works. This is the idea that I want to try to explain here further. So they went in one direction here, but what then people from the graph research team came up with is the idea, the so-called data edge contract. The data edge smart contract is just a smart contract written in Solidity that's literally just this. It's nothing. So it just has a function. Then when it's called, or even a fallback function, so we can send any function call to that contract, and it will anyways run that fallback, but that fallback does nothing. So you can think about that sounds stupid. What's the point of having a contract that does nothing when we send a transaction to it? But it actually does not it's not nothing that happens, because what would happen if someone sends a transaction to that contract is that the whole call, or the whole function invocation, every arguments, every parameters will be stored on chain. And despite nothing actually happens, but it's a way to just store data on chain. Um, sure, we can say it's not the most I don't know, like the cheapest solution to start to store data on Ethereum or any other chain. But like what's actually happening is like that we can then write a subgraph that that watches that smart contract for everything that is written to that smart contract, and that then moves logic into the subgraph. And we can have super complex logic inside of the subgraph that gets triggered just through such a data edge contract. So that's the idea here. So what's happening is that the currently mostly smart contracts are living here. They live on blockchain. They are very secure to execute, but also expensive. That we can start to move some logic inside to the subgraphs and inside yeah, inside the mappings. Okay. This is the first idea. Um, that we bring in data from the blockchain or logic, data logic, business logic from the blockchain from smart contract inside of subgraphs. Um, and then let's talk now quickly about another topic. So to summarize, first we looked at how subgraphs are extracting data from chain from smart contracts, that they are Turing complete, and then we can use them to do further processing of data. It goes so far that we can have a very extreme example where the smart contract on the chain does nothing anymore. It's just like a data storage. It's actually similar to what people are doing with Bitcoin, where there are also no Bitcoin smart contracts, right? But people are sending call data to Bitcoin, so that the stuff is preserved. Although I didn't look that deeply into it, but I have to probably at some point. So this is one point, and then we have off-chain data. Off-chain data. Now we talked about Web 2 data. Maybe Web 2 data and off-chain data is a synonym, but the idea is off-chain data is everything that is not natively stored on a blockchain. It's not data that's like someone interacts with blockchain, someone buys an NFT or sends an NFT or swaps on Uniswap or so on and so forth, but like something else. But we want to have on-chain, or we want to have in subgraphs. So in subgraphs, you can have access to off-chain data, and it works like this. So again, the blockchain can trigger, and then the mappings run. We talked about mappings to incomplete assembly script. And then they can go into the store. But the mappings also can do, like in a subgraph, every index they can access data on IPFS and on Arweave. So indexers can do that. So that's a pattern of starting on the blockchain to store IPFS hashes in smart contracts or like Arweave file IDs. What are they called? On the smart contracts, and then the subgraphs picks them up and downloads that data from Arweave and IPFS, and then puts it in storage. It's actually pretty cool. So we are now in the possibility to have not only on-chain data but also off-chain data combined inside of inside of a subgraph, and then have it stored, and then being able to be queried. In fact, we do that at the graph already. So we talked about this Web2 data class, which is server data, and that's set up like this. So in order to access data on the graph network, currently clients or like data consumers, they access it through gateways. So there are different gateways that give access to this indexers. And these gateways actually, they know a lot about the network, because like whenever a query comes into the gateways, they select an indexer, like according to some metric, like is the indexer good or does it have that data, and then sends the query to that indexer, and the indexer responds to the query, and the query goes back to the client. But like that is super interesting. Like, okay, what was the latency of that indexers? Which subgraph has the indexers indexed? Maybe even what's the error rate? Is there an indexer that has a higher error rate than others, and so on and so forth? So like there's a lot of interesting data that the gateway know about the indexes. So that's why we came up with the idea, like it's actually the data science team around Craig and Ricky, that they sent logs to then Red Panda and Materialize and all that web 2 or traditional server stuff or data stuff into a cron job, and then at some point the raw data is uploaded to IPFS, and that IPFS hash is then stored on Gnosis chain, which is pretty cheap. And like that, we are able to write a subgraph that keeps that informs us about the performance of each individual indexer and the performance of different subgraphs against each other, because the gateways all write into the same thing. It's pretty interesting. And so we have kind of a quality of service oracle about what's going on in the graph network through that setup. Yeah, I mean, like what's a caveat is that usually data on the blockchain is trustless. So we know, let's say, when someone sends an NFT around, that NFT was actually sent around. So that's kind of a high, like it's actually the highest amount of confidence that we can have in some data is when the data happened on a blockchain. But here the gateways could also lie, right? Like one gateway could just say like, like I favor this indexer because of whatever. We don't really know, like there's nothing that we can prove. But when we can say like, yeah, there are like tens or 20s or hundreds of gateways and they all agree on some quality of service metrics, then we go more in the direction of like, yeah, okay, that's probably true. Which leads also like to the next example, which would be, a decentralized weather insurance company. That would like just to kind of like bring that thought out here, similar to what we did with the gateway data. We could think of people running independent weather stations, right? Like everybody, like at some point you say like, I have a house, I run a weather station. Maybe there is a weather stations network. There probably are some projects I need to research. I would say that falls under the category of DPIN, like decentralized public infrastructure network or something like that, or decentralized physical infrastructure networks. So that, I don't know, as a house owner, at some point, you will probably say like, yeah, let's buy such a weather station, and by participating in that weather station network, I receive a small fee, which is nice. But then we can think about the map, and where we have like everywhere weather stations, so they don't necessarily need to trust each other, know each other. They should be independent. And now we have like somewhere, let's say an open air, or like probably an open air concert that wants to have like decentralized weather insurance. So now that we can think about like all these weather stations are like constantly transferring their measurement. Does it rain or does it not rain? As I said, like they uploaded it to IPFS, anchor it down to the graph, to subgraph. Subgraph collects that data and comes up with like one number. Does it rain or does it not rain? And go on and so forth. And then we can even go further and say like, then we have an indicator on a decentralized network that says, did it rain or did it not rain at that certain time, at that certain place through that setup. All secured by already, but we have in the graph network, like there's stuff like indexes have to stake. So if they can be proven to be wrong, they can be slashed. There are also delegators who are saying like, these are the good indexes, and there are the curators that say this is good data. Like this all already here, we can leverage it to build such new network. Yeah, that's an old slide, we don't break that. Yeah, let's go back on chain. So now we have a subgraph that knows if it rained, but what we need is basically, we want to have a smart contract that if it rained would release the insurance payment to the person or company that wanted to have this decentralized insurance, right? So we need to bring that data back on chain. And that's actually not that complex. So again, we have the blockchain, the assembly script mappings. Also from the top, we might have like off-chain data comes into this mapping. It goes into the store, and now there are projects like notably two or three interesting projects that would help here. It's like Chainlink. So Chainlink, I don't know if you know Chainlink, but Chainlink is also like it's an Oracle network that have like independent workers of Chainlink, and they can start to query the same subgraph like in a periodic way. and then store the result of that query on that subgraph back on chain. And similar, also like it would also work with Gelato Web3 functions. They also have something like that. And there's also like the Fala network. There's actually like a lot of Oracle services or protocols that support querying data from the graph and put it back on chain. And so when we go back to the example here, that we have this all that data about did it rain in a certain area or not, but we have it now in the graph and on RVF and IPFS. Now with the Oracle, we can actually bring it down into the smart contract that could then trigger a release of payment or not. Then we kind of close the loop. And that's basically what we think is read-oriented rollups, like that. That's how we can see the graph and subgraphs as read-oriented rollups. So yeah, rollups as a recap. I mean, like we have the L1s and the L2s, and on the L1s, the blocks are produced. They are very expensive. On the L2s, also like there are like new blocks, or we can also say a state, and then just just the summary gets written down. That's a way to scale, right? We can also think about read-oriented rollups where the data, as I say, like it's just it's a block. They go up, they get processed, and then with oracles they come down back into the blockchain if needed, and they can be further processed and go up and down. So like it's very simple. That's why that technical term read-oriented rollups came up. Yeah, maybe a last word about verifiability or data integrity. As I said before, like we have the so-called proof of indexing. Like the graph network already has like some measurements implemented to make the data more trustworthy. So like when indexers, for example, index data, when they see data, they are independent indexes, as we said. They submit proof of indexing on chain. So they hash the data that they saw and put that on chain. So we see if all the indexes agree on that data or not. So that's already pretty good that we know that. And then on top of that, it's like when an indexer receives a query, then they give an attestation with the response. Basically say like me as an indexer, if you say like it's a Simon indexer, I say like this is the correct answer to that query. And if you can prove me wrong with this so-called attestation, you can slash me. So that's the way we currently look into like how can we that make more automatic. But as of now, this is what we have, which is already better than any Web2 service. All right, I think that was it from me. 3 minutes early, but yeah, I think maybe we have some questions to discuss.
Yeah, no, that's perfect. Thank you, Simon. That was really interesting, and I love that you really gave the full picture of how the graph is able to really connect Web 2 and Web 3, and also Web 3 back to Web 2 as well, in essence. So that's really cool to see, because I feel like if the world was to take up Web3 more and blockchain and crypto, they got to see beyond just like, the Bitcoin price going up and Dogecoin and all of that stuff, and look at the underlying technology and how that could really help real life. And yeah, I really like that that weather insurance idea that you had. That's really cool. That's something I never thought of before, which ties in pretty well with the first question that we got from the audience is yeah, since the graph has its own track in UHack, what are some cool subgraph examples that you personally like?
Yeah. So actually, maybe I can share. Do we still see my screen?
Yeah, your screen is still live.
Okay, so I'll go to the graph.com Explorer. I mean, generally, like it's interesting. Like the curation is not a bad. It's not a bad metric to see which one are the good ones. Obviously, a lot of people look into this the Uniswap one, but like I would look at the ones from Messari actually. So Messari, it does a very good job in creating subgraphs. And the cool thing about Messari subgraphs is like they have verticals. So they say like, oh, this is decentralized exchange, or this is the lending protocol, and or this is this, and then all that the decentralized exchange and the lending protocols, they have the same schema, so we can start to compare. Maybe we can even do this quickly. So I could open up the Uniswap, no, not the Uniswap, but let's say the Aave, and the MakerDAO. Then we have, okay. Okay. That's the split view from Arc. So we have a playground, and when you go into playground, here is the Explorer. So what would be probably interesting is the so-called protocol. Yeah, the protocol. Yeah, cumulative. Yeah, cumulative protocol side revenue. I don't know. So we can send this one, and can we see like, okay, this cumulative protocol side revenue in US dollar that Aave did is, I don't know, 21 million, no, 22. And we can take this exact same query, go to the other subgraph that is in the same category, and send it, and then we see what's Maker's number here, which is a bit higher, huh? 255 million.
Yeah, a tad bit. Yeah.
So that's very interesting. Like we can start to look into these Messari subgraphs and start to look at the different protocols and come up with how we want to compare them. And it's right here at the fingertips.
Nice. That sounds like a really awesome use case. All right. The next question that we have up is, how decentralized is the graph, and is setting up nodes incentivized in any way?
Yes, that's a good question. Um, so the graph is the decentralization of the graph is basically twofold, like how many indexes are there, and yes, it's incentivized. So the tokenomics there is like if you if you join the graph as an indexer, you have to bring a minimum of 100k GRT in self-stake. And then with 100k GRT in self-stake, you can attract up to 16x in delegation. And then with that one, you can start to index subgraphs. And with indexing subgraphs, there is a protocol reward. I think it's currently at 2.9% per year of all GRT will be distributed across the indexes that are indexing subgraphs in that way. I skipped a lot of details because it actually is quite complex. But like there's an incentivization to run an indexer to do so. And I mean, there are 200 and let's say like 200 indexers currently. So I mean, like, yeah, it's not the same as Bitcoin is decentralized. Although there is also like they are mostly running in these farms, so like the independence of those indexes is higher.
Yeah, I guess that's fair. Like a lot of people just don't have the technical knowledge or the funds maybe to set one up themselves. And a really interesting question that we have been getting throughout the morning session is that I think is also really interesting, especially for people who are looking to start their own projects and really get out there and make something happen, is what is the graph's revenue model? From where does your revenue stream come from?
Yeah, the graph, yeah, so basically the main revenue is query fees, and that's I said, like, so if someone sends queries to the graph network, someone has to pay. So it's mostly the projects that pay. The subgraph developers can take up to 10% of that query fee. So like it's a possibility to participate just as a developer in that value creation or value capture if you want. Yeah, there is like up to date 3 million in GRTs. went through as query fees. So that's basically the business model here. Does that answer the question?
Yeah. I think that's cleared. I was just looking at somebody else just dropped that question in the chat as well. Yeah, okay. And just to close it all off, I'm really curious because from what you were explaining earlier, it seems like there's the possibilities for the future are kind of endless. But where do you see the graph in, let's say, 5 years time from now?
Um, yeah, there's a lot to come. Like I think definitely more and more features. I think like the graph, what I currently see is like the blockchain's ecosystem gets more and more scattered. Like there are more and more different blockchains, there are different technologies that compete, and you have the whole L1, like the L2 stuff, data availability, protocols, and so on and so forth, which is very good, which basically builds the infrastructure. But like to access that myriad of stuff, it gets more and more complex because there's so many different moving parts. So the graph can, and I hope it will, like form this unifying layer on top of it that makes it very easy. I mean, I don't need to understand like what exactly goes on, which blockchain I'm just querying, and where is that thing happening. But I just have like a very simple graphical interface that I can get the data out. And I think this is where I think currently where it's a little bit going.
Nice, awesome. So no the graph weather insurance company in the future?
No, sure. But yeah, that is so much going on there. You know, like the data is an IPFS, that IPFS data needs to then go there and blah, 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 and then goes into the graph and goes back. But like as a consumer, I just have a subgraph that tells me this is the truth.
Awesome. All right. Thank you very much, Simon.
Yeah.
It was really great talking to you here today.
Thank you so much for having me.
All right. Take care. Goodbye. All right. Awesome. So that was Simon from the Graph. I hope you learned something new, something interesting here. I definitely did. Next up, we have the Fireside Chat with LayerZero, and we have Justin from the Cambridge Blockchain Society here. And they're here in the call with me right now. Hello, guys.
Hi, thanks for having me.
Hey, lovely to meet you. Thanks for having us.
Yeah, nice to meet you guys. From what I know, you guys are in ETH Denver, so that's pretty cool. You get to meet in person as well.
hmm
Yeah,
Yeah.
how are the events coming on? Did you guys meet at Build House yet?
We haven't yet, but I'll be with Justin in about 2 hours filming a podcast. I am sat outside Union Station. It's gorgeous. It's so sunny.
Yeah,
All
yeah,
right.
we will yeah, we'll be in person in a couple hours, so that's exciting. Well, we've met a couple of times in person before, so
Yeah, in London.
catching up.
Nice, awesome. I've never been to a crypto conference myself, so it's a little bit of shame I'm doing this from home. Uh, but yeah,
Next
anyway,
year.
exactly. Next year, I'll be on that. From what I know, you guys prepared with a topic, and so yeah. So I think the way this should be structured is you guys should shoot the questions, do the fireside chat. I'll jump in if I have anything smart to say, and at the same time, we're still open to questions from the audience. So if then anybody drops questions, if it's relevant to that discussion, I'll just try to cut in between at some point. If not, I'll save it for the end.
Sounds fantastic. Okay, so yeah, I'll introduce myself and then I'll let Irene do her much more important thing. So my name's Justin. I'm from Cambridge University, and I'm part of the Cambridge Blockchain Society. And this is Irene. Do you want to give yourself a bit of a background before we get into the real meat of the conversation?
For sure. My name's Irene. I'm head of strategy at LayerZero Labs. I joined LayerZero Labs about 2 years ago, originally as an integrations engineer, and then went on to be our head of BD and integrations, and now focusing on overall strategy of the protocol and company. We are the developers behind LayerZero, the leading omni-chain interoperability protocol, and also the original creators of Stargate Finance, which is the most widely used native asset bridge. I am calling from Denver. And so I've had a lot on my mind. I've met a lot of students this week. Really excited for this fireside.
Fantastic. Yeah. So, do you mind giving us a brief introduction, like an explain like I'm five version of what LayerZero is, and kind of how you got into LayerZero and what your background previous to blockchain is, and what kind of made you excited about LayerZero in particular.
For sure. I got into crypto in a very roundabout way. I was a college dropout. I was studying computer science and I left school 6 weeks into my freshman year. Very atypical. Moved to New York. I was working on a menswear company, and it just so happened that our first two investors for this startup were Tyler and Cameron Winklevoss, who are OGs in the Bitcoin space. I read the white paper. From there, started trading or really just buying crypto and holding. When I went back to university, my research was on anti-surveillance technology, and the ideals of censorship resistance are very aligned with this. I studied computer science and also a lot of American history. And when I finally dropped out, was on the venture side, investing in AI tooling and also blockchain infrastructure. Interestingly, I did not enjoy the venture path. I often say this a little bit tongue in cheek, but I felt like I was becoming a really awful person. I have many close friends who are VCs and I adore them, but I was a high performance athlete for many years and I was playing a team sport. Venture capital is an individual sport. And if you're highly competitive, it brings out different traits and different behaviors. So I wanted to go back to playing a team sport. And at this time, building a protocol, this was around 2021, is about as much of a challenge as it gets with a group of ragtag, under-resourced people. And I asked myself, if I were to make one last investment as a VC, what would that be? And at that time, it was something in interoperability. It was very obvious to me that there would be multiple chains. BNB chain had already launched in 2020, and it was shocking to see how much user adoption there was and developer demand. And the bridges that existed were very rudimentary, very insecure, and yet there was demand for movement of assets between chains. So I looked at every single bridge, every messaging protocol, diligenced it like a VC, and then narrowed it down to two teams that I thought were most likely to win in a winner takes all market. And LayerZero was one of them. I actually cold DM'd a person on the team and ended up, stars aligned. They wanted to bring me onto the team. And now we are building immutable infrastructure that specifically solves for the challenges of sharing information across chains. Bridging is just one use case out of thousands for what you can do with arbitrary contract invocation. And what I mean by this is with LayerZero, you can actually just share data from one smart contract on one chain to a smart contract somewhere else. We are a layer below bridges, and we are a cross-chain messaging protocol. So effectively what LayerZero does, it is empowers developers to build on multiple chains. And the last point I'll say here, and we can dive deeper as you guys find interesting certain areas, is I look at chains like programming languages rather than sites for commercial real estate. You sort of pay a tax by choosing what chain you launch your protocol on. For example, let's say you're launching a DEX. You could be a Solana-based DEX, sure, or you could be a chain abstracted fintech platform, like just a DEX. And you could use ZK EVM for settlement. You could pull in liquidity from Ethereum. You could have users be able to trade from their home chains. You would never think to yourself, I really love C++. What can I build with C++? And right now, that's the way we're approaching different chains. With LayerZero now as a highly expressive, immutable primitive, you can look at different chains like tools that you can stitch together to create this ideal user experience.
Wow, it's a fantastic background. Yeah, really interesting to come from high performance athletes to creating interoperability. And I think there's something to say about that. In team sport, you kind of allowing the blockchains to act as a bit of a team in that kind of sense. And so I guess as like a high level takeaway from that, LayerZero is an immutable cross-chain messaging arbitrary messaging system that allows essentially seamless communication and developers to build on top. And what they build is kind of up to them, but it allows kind of this unification of liquidity. Okay, fantastic. Do you mind just kind of if we dig in a little bit into that in terms of the architecture and how LayerZero, the V1 works specifically, and then we can kind of move into how V2 is an adaptation to that.
Yeah, for sure. And let me know if the wind is making noise until I'll relocate. I think it might be a little bit. LayerZero V1, we created driven by these three design principles. And I talked about this the other day at the Stanford Symposium. When our founding team looked at the bridges that existed around 2020, they were all wrapped asset bridges. And what wrapped asset bridges are is a smart contract that's custodied or owned by a third party, let's say some multi-sig, some team that raised venture funding. Users then submit or lock their funds into the smart contract. And then on the other side, you're minted a certificate. So that means you're minted something that's like a coupon or an IOU saying it represents the value you have in this contract that you're trusting us to secure. Now, the challenge is a lot of these bridges are made with upgradable smart contracts. So if the owners of the contracts decide to make some change, maybe even a positive one, like we want to make the bridge better, and they introduce some vulnerability, then this bridge can be hacked. And we've seen that with the wormhole $360 million hack, the multi-chain hack, many others. The multi-chain hack had issues with the multi-sig, but effectively these were all wrapped asset bridges. Our founders didn't want to use this for the game that they were creating. It was actually a multi-chain game they wanted to create. So they set out to build a bridge, but realized that bridging is actually just one use case for messaging, and the layer below is a lot more interesting. The design question then is, how might you build a messaging protocol that is both evergreen and also evolvable with research and time? So you guys are at institutions right now. You probably engage in research with your professors. If you believe in science, if you believe in effectively like what humans can create by coming together and studying things and trying new things, then you're probably aligned with me in thinking that the best validation methodologies of 2022 are not the best ones of 2024 and certainly not 2030. So you have to create an infrastructure protocol that where it is important cannot change, right? Because if infrastructure, it's almost like if the basement of your house can suddenly be removed, then the whole infrastructure will fall apart. However, it also has to be able to accommodate new features. So the design principles that came out of that were 1, immutability, 2, permissionlessness, and 3, censorship resistance. V1 achieved all of this. However, there was feedback that led to V2. So I'll start with V1. V1 is composed of immutable endpoints. So these are smart contracts that are deployed on every chain that we support. So imagine there's a LayerZero endpoint deployed to Polygon, one to Optimism, Arbitrum, etc. These endpoints are what your contracts communicate with. So if you are deploying a token that's omni-chain, you have an LZ send function in one of your contracts, and that function is what calls to these endpoints. Between the endpoints are these off-chain entities, and in V1 we used oracles and relayers. What an oracle was any entity that could retrieve and submit a block hash, and a relayer was any entity that could retrieve and submit a transaction proof. And the idea was these two entities, or plural entities as consortiums, had to be independent and non-colluding. Now, the hypothesis was that many teams would run one of these components themselves and further decentralize. Say, they could use a ZK Lite client, they could use a Chainlink oracle and run an oracle themselves, and then choose a relayer. Find diverse oracles is very important to avoid centralization risks. The challenges, though, were that we had created this setting called defaults in V1. These are meant to just be for testing, but defaults had one oracle and one relayer, and the relayer that was used was one built by LayerZero Labs. What we found is most engineering teams are actually very lazy, and it's because you're doing many things. I actually can relate to that. Choose the path of least resistance, and so 95% of teams chose defaults. That meant that they were using an oracle that along the spectrum of centralized and decentralized was a lot more centralized, and was using the LayerZero Labs relayer, which posed potentially a liveness risk, because if this relayer went down, which it never did, but if it had, then messaging would halt. There would be no exploit, but it would mean that if you're operating a cross-chain trading platform, there would certainly be a user experience issue. V1 achieved enormous product market fit. We passed 100 million messages. More than 600 applications have integrated LayerZero V1. And V1 is, for what it's worth, the most secure messaging protocol that exists. It's secured $50 billion of value and has been live on mainnet for 2 years. However, V2 has addressed a lot of these issues, and I'm really, really excited to dive into some of those. I'm going to stop there. Justin, was that a clear explanation? What outstanding questions do you have about V1?
Yeah, that's a great introduction to V1, I think. So just again, a summary of existing, alternative bridge cross-chain messaging systems are that you require trust in a lot of the smart contracts on the source chain, and then every kind of activity that's based upon them relies on the trust of the bridge, and that obviously can create a destabilizing effect for the entire network. Whereas LayerZero, you create this in theory a decentralized mechanism, but ultimately it's trustless because you have two mechanisms that are non-colluding to allow for verification of a validation for a transaction on each chain. And I think that's a really interesting point. And do you mind just expanding a little bit on why you guys chose those two verification mechanisms rather than how they do traditionally? Like what about those two mechanisms makes LayerZero so much better than everyone else?
For sure. One thing that I think you articulated really well was the alternative or what existed before LayerZero, which I define as services. So what is a service? It's a product that relies on the liveness of the creator company to maintain the integrity of the product. To give you an example, it means you're using something, and if suddenly that team runs out of venture funding or they just disappear in some horrible accident, you can no longer rely on that product. By contrast, a protocol is a product or a primitive which can exist and live up to the value proposition in perpetuity without the liveness of its creators. TCP/IP is a great example of this. It is a protocol that allows the internet to scale. There is no team with venture funding behind it. And primitives like different contract standards are also examples of this. We built LayerZero to be specifically a protocol. Now, how did we achieve that? And to answer your question, why did we choose the model for that validation layer? By having the off-chain entities be permissionless, meaning anyone can run an oracle, anyone can run a relayer, and you can choose which ones you want always. It's modular in that respect. You're not reliant upon LayerZero Labs to determine the security. So we're actually unopinionated how messages are validated. If you believe in ZK-like clients, you should be able to use that. If you believe in a large set of validators, which is, Wormhole, they do 13 out of 19 validators, that is their fixed monolithic approach to security, then you can use that within the LayerZero framework. V2 certainly makes it a lot easier, but the ethos that we're trying to articulate through our protocol designs is that we believe in the choice of developers. Developers should own their security rather than delegating it to a team like LayerZero. When you delegate your security, let's take Nomad, for example, that was a really unfortunate hack that occurred to a very talented team. You are trusting them with, say, upgrading contracts without introducing vulnerabilities. Writing smart contracts is very difficult. If you have opted into using something and a team makes a change, even a well-meaning one, and there's a vulnerability, there's contagion risk for everything built on top of it. So LayerZero was a pretty radical invention because the endpoints themselves are immutable. With LayerZero v2, we simply just deployed another endpoint, so you can point your contracts towards those. It's append only and opt-in. But then the validation layer is highly modular and configurable at any time, and it requires no new code. I hope that makes sense and answers your question. I think once we start talking about V2 and how we've addressed some of the feedback we got, it should hopefully really click.
Yeah, thank you so much. And just on that, I think you explained it really well in terms of where you, with the traditional systems being like a single point of failure, this two mechanism verification system allows it to be, you can't just hack a single point, you need to validate twice. So it increases security quite significantly. And so actually that's a good point about to move on to, what in your how in your team did you guys approach moving forward and looking at competition and seeing how that might influence how you guys move forward? And then additionally to that, because the LayerZero is predominantly builder to builder, and so what feedback did you guys get, and how did that kind of move you on to thinking about V2?
So V1, again, was incredibly successful, and it still is. A lot of teams choose to use it because it has been hardened over time. Like when you think about security, you should think about value secured over how much time. However, for me, and I mentioned this before, I dropped out of university at a very young age. I had like $100 to my name, and I would sometimes do hackathons to make money. With V1, if I had wanted to decentralize my own validation layer, like run my own Oracle or relayer, there was just no way I would have been able to do it because the relayer in V1 has to handle both validation and execution. So that would mean that if you wanted to build a performant relayer, you would need wallets on every single chain you were supporting with gas tokens in them. And also you would probably be paying for many, many RPC calls a month. I don't know a single, hackathon participant who would see that as accessible. So if that's not accessible, then decentralizing your implementation of LayerZero v1 is actually like not easy and therefore not the status quo. And the status quo of how people use your product is what your product is. So with V2, I constantly asked, is this something that an 18-year-old with a short attention span and very little money to their name could actually decentralize? With that in mind, we made some core decisions around how that validation layer would look. We decoupled execution and validation from the relayer and instead created this commoditized role called the executor. And when I say commoditized, what I mean is the executor does not provide any security to your cross-chain messaging and simply moves the message once it has been verified. So once security has passed, and this is a permissionless role, LayerZero runs one, you can run one, or your users can go to LayerZero scan or some explorer and pay for the message themselves. That eliminates any reliance on LayerZero labs. And because an executor is so much easier to build, an 18-year-old at a hackathon could actually do that. And we have open source reference implementations. On the security side, we created a security stack that is made up of DVX. That stands for Decentralized Verifier Networks. What can be a DVN? Any entity that can validate messages. That could be a native bridge. It could be other bridges like Axelar and CCIP and Wormhole. It could be a ZK Light client, a ZK Oracle. It could also be a consortium of delegates. On day one of mainnet, we had more than 20 DVMs live and in our docs. Again, permissionless, they're not run by us, that use different validation methodologies. So an example is Polyhedra built a ZK Light client. The Nethermind team uses a consortium of geographically diverse validators. Now you guys, if you're at a hackathon and want to deploy, say, like a Justin token that's omni-chain, and you want to have it be secured by using a ZK Light client and the Nethermind DVN, you can select those two, say both of them have to agree, and I'll use the LayerZero executor. And then let's say a year from now, the Justin token has like a $1 billion market cap, and you want a lot more security for the transfers across chains. You could then push a configuration change and add now to that Axelar, because let's say you're excited about their middle chain model. And so now it's maybe a 2 out of 3, and you require that the Nethermind DVN must sign in. So this X out of Y out of N arrangement is how these security stacks are configured and limits the amount of new code you have to write. So to summarize it, what really dictated the decisions we made about V2 were around the developer experience and also the ease of decentralization for this ideal persona of a college dropout.
Thanks. I think that's a really interesting way of moving forward because, as you said, the original thesis was still the same in that you wanted to create this decentralized way of doing cross-chain messaging, and the practicalities may have changed that, or they weren't as realistic, or just didn't pan out quite the way you had imagined them to. And so moving to V2 makes that a lot more practicable. So with that, actually, I know you're mentioning when you have, let's say, the Justin coin decides to create more pending solutions to my security. Do you mind just diving a little bit deeper into the library upgrades and the append only additions to V2? So just as a summary from before, if you don't mind just giving a brief overview of the architecture and how that kind of expands onto the architecture.
Absolutely. So how LayerZero achieves modular security and is a protocol that responds to that design question I mentioned earlier of how might we design an interoperability protocol that is both evergreen and also evolvable with research and time, is the endpoints, which are essentially the gateway contracts or what your contracts communicate to, are non-upgradable. Now, how do we then implement new features or upgrades like LayerZero V2? We deploy an entirely new immutable endpoint. And in a library, almost like a folder on your MacBook, it sort of can open and collapse. There still is endpoint V1. You can always use that. You can opt into it. And there still now is endpoint V2. We can't make any changes to either of those. If we wanted to implement some change, we would have to deploy an endpoint V3. And what this means is if you have opted in for Justin token to use endpoint V1 and we deploy endpoint V2, you would have to proactively change and opt into V2. This means that you have the time to vet the contracts. You can ask your community, you can ask your DAO, do you want to switch to V2? V2 is backwards compatible with V1. It eliminates the contagion risk of a new deployment that we might make and the impact it could have on your community. Because again, if LayerZero Labs disappeared, you should be able to leverage the protocol in perpetuity. And the way these immutable endpoints work allows you to do that. And then in between that is the modular security. That's where you can, without writing new code, change out the validation methodologies you use and also the size of the security stack. So as you want more security, you pay for more gas and you add more DVMs into this, or maybe these DVMs use different methods like using ZK proofs or optimistic oracles, things like that.
Okay, so on a very high level, V1 created the basic core infrastructure, and rather than having to implement new versions every time you guys look at the future, and as I think I was listening to a recent talk of yours, we're unsure how we would best validate transactions in 5 years' time or validate security in 5 years' time. And so the best way of doing such a thing would be to leave it potentially open-ended, but allow for maximizing security with that. And the ways that you guys have come about with that is a very smart idea in modularizing that security. Is that a fair overview?
Yes, absolutely. And for developers who are listening, you can go to our new docs and there is a very concise message flow diagram, and you can see the endpoints on the left-hand side and the right-hand side, and then that modular security stack in the center.
You're one step ahead of me. I was just about to say, and I think the question still probably stands. For developers, as this is aimed towards the developer community building on potentially on LayerZero using Conflux, what kind of advice, or what's the best way of going about building on LayerZero right now, and what kind of advice would you give to people in your position at university, maybe with $100 in their bank account, hopefully winning the hack house? What kind of advice would you give them?
It definitely depends on what you're trying to build. But as general practice for cross-chain applications, let's say you are working on a project that is on Conflux, but you also want there to be like a really easy user flow from the OP stack. I would start to get familiar with our contract standards, and those are really easy to deploy and experiment with. So the OFT standard, which stands for Omnichain Fungible Token, we have those open source in our docs. Deploy them and play around with choosing your DVM configurations, and that will help you get familiar with the unified semantics for LayerZero. What I mean by that is, unlike other messaging protocols, the way you build with LayerZero is the same on every chain, even if it's EVM or non-EVM. Obviously, there may be different languages, but like the syntax and design patterns are the same. We also have some other like onboarding flow things, like you can do a ping pong example that we have. So it's like sending a message from one chain to another. Um, that's great. And then I also encourage you guys to reach out to our DevRel team if you have more novel design ideas and want some support for this hackathon. And also anytime we have DevRel that are all hands on deck. So you can reach me at Irene Wu, IRENEWU27 on Telegram or on Twitter, and I'll route you through someone or even personally answer your question.
Thanks, that's very kind. And just like a general philosophical question, where do you kind of see the blockchain space in the next few years in terms of how does this seamless cross-chain communication fit into the ecosystem, and how is that impacted with the Ethereum's kind of roadmap with universal sequencing and then single slot finality?
These are great questions. A few things come to mind. I think the first one is people are asking, are there going to be thousands of app chains and L2s? And certainly with roll-up as a service providers and really elegant stacks like Arbitrum Orbit, for example, it's a lot faster and cheaper to spin one up. That being said, there still is a cost to it. And launching an L2 or roll-up does not immediately give you product market fit. I think there's like this short-term validation around it because like token price go up and everyone's really excited and now venture funding's back. Maybe we see like a huge spike up to hundreds or thousands, but I think it will settle back down. And there will be closer to, let's say, like 100 of these app chains, at least for the near future. Now, there isn't an inherent way to have unified liquidity and seamless information across these, particularly if you have the OP stack and also Arbitrum Orbit and Polygon CDK. So LayerZero will be incredibly important in this way. OFTs, I think, will continue expanding adoption. With OFTs, you have horizontal composability. So rather than going from an L2 and doing the 7-day bridgeback period, I mean, once you do that, you really can't really transact with UFI. And then going back across to another L2 bridge, you have one click, one gas token, and a mint and burn to move from one L2 to another L2. So when we see gaming companies like Zai on Arbitrum integrating this, ApeCoin is now an OFT. A lot of liquid restaking tokens are OFTs. And then I guess not really a hot take, but now an observation around L2s more broadly. Many of them have ambitious roadmaps, but most of them have not actually created their plan or infrastructure around inherent interoperability. It was a vision that they stated. It's an ambition. And so we have things like the superchain or Orbit or Ag Layer for Polygon, and it's all very early days. I'm meeting with their product teams and helping with this, and I'm super excited about the ideas they have. But I would not expect in the next 2 years for the like L2 experience to be incredibly seamless.
Thanks. And just finally, I guess topically, with potentially restaking summer coming up, what is your view on that generally, and where do you think LayerZero kind of fits into that?
I am a huge fan of the Eigenlayer team. So I'll start by saying if there was a team to build that narrative and also evangelize it, they're fantastic. Two ways where I see LayerZero fitting in are one on the omnichain fungible token standard side. So for many of these liquid restaking token protocols, it's a no-brainer to make these tokens easily transferable across many different chains. And then something else that's interesting is there is a world in which Eigenlayer could actually power a really interesting DVN. And this DVN would use the economic security of users who restake. I don't want to tease too much, but that's something that I think teams like theirs are really interested in. LayerZero has massive distribution. We do have overwhelming market share around cross-chain messaging. And right now, the DVNs we have use different methodologies. None of them are centered around economic security or like bonding.
Thanks so much. Yeah, that is a really exciting prospect. I think LayerZero has so many applications in so many areas of the industry where if we all kind of listen to the same ideals as that, where we have immutability and trustlessness, I think the industry will move far further, much quicker than it currently is, and allow a lot more people to be able to engage in efficient DeFi more quickly. But yeah, thank you so much. I don't have any other questions right now. I don't know if anyone else has any, but yeah, thank you so much for your time.
Thank you guys. Actually, can I ask you a really quick question, both of you? What is the sentiment around crypto on university campuses right now? And for teams like ours who have like very resolute ideals around censorship resistance, for example, and permissionlessness and immutability, what is the best way to like engage with students in this? What's resonating right now, and where do you think industry is failing students?
Do you want to go first?
Yeah, sure. And just before we close things off, we do have a few questions from the audience, and I have some in mind as well. Before we put an end to this session, but yeah, it's really interesting that you would ask that. Not a lot of my friends are all that into crypto, and those yeah, it would be a pretty bad example actually to ask that question, because I know around 2-3 people who are into it, and they're mostly into the airdrop side of things. But from other people outside of university, they do see the aspects of DeFi being a really big thing, of real world assets being a really big thing that crypto can really revolutionize. And yeah, I don't really have a concrete opinion on that. I'm relatively new to the space myself, so I'm still kind of exploring it. But I do see the ease of access to financial tools for people being a really advantageous part of crypto and blockchain as a whole.
Awesome, that's very helpful. It affirms what I was thinking, which is that crypto has not deeply penetrated college universities in campuses, but that's on us, like people in the industry, to I think educate better.
Yeah, for sure. I can definitely resonate with that. I think the sentiments around blockchain and crypto generally follows the cycles of bull and bear run. Um, we this last 6 months, 8 months, we've actually had a massive uptick in interest. Coming back, we run an accelerator now at Cambridge, and we have weekly brunches where we have technical talks and then business talks. And so I think the sentiment around that generally has been a lot to do with privacy. A lot of people are focusing on how to maximize privacy. And I think from a traditional perspective, it's quite difficult to imagine using public blockchains for really like private transactions. For example, my healthcare data or my actual financial data. If I can look at and see what activity I'm doing on chain. And so how to obfuscate those is like really people are focusing on that. So with that, like ZK and FHE have been significant areas of interest. There's a few PhD students who are doing their PhDs in FHE and how that can be implemented into public blockchains, which I think would be really interesting.
Very cool.
But with that, I think the overarching idea is always omni-chain interoperability. I think people have kind of gone away from the one chain's gonna rule everyone, and each different blockchain has its own nuances and its own benefits, which I think if you could have an omni-chain world where each chain is equally as accessible as the next, you allow builders to optimize on what they would like to focus on.
Awesome.
Right.
The other questions?
Yeah, now I'll shoot some questions that the audience is sending in. I feel like we've talked about this, maybe not extensively, but I think I feel like we covered this, but maybe you have something else to add, Irene, to this. Like the audience is asking, why will LayerZero be the messaging protocol compared to others like Axelar?
I'll try and keep the answer succinct. I do think it's a winner takes all market, and I think, frankly, many of the other attempts to solve interoperability have resulted in hacks. And when I was choosing which team I wanted to join, the team that would build a true protocol that would persist far beyond my time, it comes down also to just like the security practices of your team. And I'm incredibly proud of the fact that we have never experienced a vulnerability, and the way that we ship code is almost like NASA level standards is the way that we put it. Now our architecture, I think, is one that actually does evolve with time and maintain security, and I think is one that can eliminate dependence on LayerZero labs. That's key. Like something that actually wins and persists is something that does not rely on a group of people who have venture funding.
Yeah, awesome. I really do feel like it's really interesting that you would say that this is a winner takes all market. In the current state, I would do see point in that. But as you said yourself, who knows where we'll be in 5 years' time. All right. Another question that was thrown up was how decentralized is LayerZero? How many DVNs are there, and is setting one up incentivized?
Right now, there are about 30 DVNs, I believe, listed in our docs. So they're all live on mainnet for you to choose from. Is running a DVN incentivized? Our launch partners are running these as a public good right now, but with our eventual launch of the token, which will be, we've already announced this at the end of H1. Yes, DVN operators are really important parts of our community. So I'm sure you can read between the lines there around how important it is to ensure we have client diverse DVNs, meaning not DVNs that are all operating using the same stack. And how decentralized is LayerZero? Rather than taking the monolithic security approach, which is, look at Axelar and CCIP and Wormhole, basically they define for you how messages should be validated. They think it's 13 out of 19 validators, or a chain, meaning like you have to trust that your messages will flow through this chain they built and get there securely. We are unopinionated at that layer. So LayerZero can be infinitely decentralized, or it can be priced at a more appropriate range given what you're transacting. So if you're building a game that's moving 5-cent NFTs between different app chains, you probably don't actually need to pay for very, very high security. But if you are launching a stablecoin, you want to scale that security up. It's not on us at LayerZero to impose our views. And I think with the internet, you can build good things and you can also build bad things. You can build YouTube or you can build a phishing website. Our ethos at LayerZero Labs is very much aligned with that, almost like cypherpunk ideals. And we want to see what people come up with.
All right, and speaking of wondering what people come up with, I feel like this can be coming from someone who's interested on building LayerZero. They're asking, with the OTF, do you need to deploy a contract on each chain that you want the token to be available on?
Yeah, so with the OFT standard, if you have yet to deploy your contract, what you would do is deploy the native OFT contract on the chains that you want the token to be interoperable between. And at any time, you can expand that in the future. So LayerZero will be adding support for Solana soon. Let's say you now want to have your token be able to move to Solana and back. You would simply deploy the Rust OFT contract or the Solana implementation there and hook them up. They have the same contract addresses. If your token already exists, you would use the OFT adapter contract on, let's say, mainnet or wherever you've deployed your token. And then from there, it will communicate with other OFT contracts you've deployed elsewhere. It takes about, I'd say, 15 to 30 minutes to deploy each of the new OFT contracts. So it's a lot quicker than natively deploying, let's say, the way Circle does for each of the chains they add USDC to, which is months between each deployment.
All right, awesome, thanks. And just to concretize things a little bit more, like just in the talk with Simon earlier, he said a really interesting idea about a use of the graph, and I feel like LayerZero could be very similar to the graph in that sense, where it's a great infrastructure that people can build endless different tools on. And I'm wondering what if there is a specific use of LayerZero that you really like, that really stood out to you, and well, yeah, and that, and if there are any specific use cases that you're really excited for in the future.
Yeah, at the Stanford event, I spoke about the first few applications that have built specifically on V2. The first one was called Clusters. If you're familiar with 0x Fubar, a well-known sort of security threat or on crypto Twitter, an amazing developer. He created an omni-chain, essentially like namespace. So you have all of these wallets on all your different chains, and there's no way to unify them. Now with Irene backslash, it collapses all of my cross-chain wallets into this. Incredibly powerful, and used LayerZero V2 in a great way for that. There's also a new standard. It's ERC 6551, which is a standard that enables NFTs to have wallets within them. Or think of it as like NFTs that have folders within them. So now NFTs can express, NFTs can act on different chains. And I'd encourage you to look into that. We announced at MPC Day this week that every single ERC 6551 is now natively cross-chain using LayerZero V2. At the end of my talk, I had a call for ideas I want to see people build, or like a wish list. I can share this with you guys later. But some things on that wish list are like true cross-chain borrow lend. So you should be able to borrow on one chain and or like lend on one chain and borrow on a few others in one click. I would love to see. I'd love to see a game or like some sort of social consumer experience that has like an action on one chain triggering a change to an asset on a different chain. So in a game context, that would look like I accomplish something on an Avalanche subnet, and then my NFT that's on Ethereum suddenly has a crown, and I use it for my Twitter PFP, and Twitter immediately recalls the metadata, and now it's changed there. Those are really simple, but you guys are the creative ones with these primitives. Think about anything that can be solved with arbitrary contract invocation, meaning something happens here and then something happens here.
Awesome, cool. Thank you for that. And if you guys have nothing else to add, actually, if there's any final thoughts that you'd like to share to our listeners here, then yeah, maybe I don't know, to get them motivated, or any words to get them going, then please feel free to
Yeah,
share them.
I mean, I was once in your guys' position, and I think what you can accomplish as a student is far beyond what you can even imagine. And I think this industry rewards the ostentatious and the bold, or the people who really back themselves. So, let this not be the last hackathon that you do. Try many more things, and like take risks. Right? As students, there's a lot that you can do that once you're not affiliated with a university, you can't do. The .edu is super, super powerful. And I'm always here as a resource. I love talking to students. I can't promise that I respond quickly, but if any of you are thinking about dropping out, or you're just wondering like, how do I achieve like this dream I had within crypto, send me a message on Twitter, and I'll share some thoughts.
Great, fantastic. Thank you so much for your time, Erin. Really appreciate it.
Awesome.
All right.
Okay, bye guys.
Thank you guys so much. Have fun at ETH Denver.
Thanks. See ya.
All right, and with that, we finished the Fireside Chat with LayerZero. I hope you enjoyed that. I really did enjoy that session myself. So yeah, don't forget to tune in for the next week's speaking session, which will be the final speaking session that we have. Thank you very much.